Okay. Good day, dear colleagues. Thank you that you joined in for our workshop. My name is Natalia Arvachova, and today I would like to discuss with you how many important things in nuclear can be connected together in digital INC systems. As you know, when we talk about the nuclear power plant, we always think about the reactor, fuel, turbines, etc. However, all NPP has a brain, and the brain of NPP is one of the most important things, especially when we talk about the safety INC systems. The agenda of the presentation is displayed on the screen. When we talk about the INC system in nuclear power plant, we really often hear the word safety and functional safety. But what exactly functional safety does it mean? The International Society used the umbrella standard IEC 61508 to define functional safety. The definition from this standard you can see on the screen. And if to be honest, when I read it first time, second time, and even third, I didn't understand what is it. However, in this definition, we can see one of the most important things. And it's the most clear thing, risk reduction measure. So, when we talk about the functional safety, we always talk about the risk management. And you can agree with me when I talk the risk management is a most popular things all over the world. So, functional safety in INC system is a way how to reduce the probability of any accident or reduce their consequences. When we talk about the safety system, it means that safety system is the system that perform safe control of the critical technological processes to achieve functional safety goal. So the system with functional safety shall allow you to avoid the accident, or in case of accident, it allows you to minimize the damage. All about risks. And you can see that functional safety is the composite parameter. Another thing that we hear about the functional safety of INC system is SEAL 3 level. I'm sure that you heard it many times. And the definition of what is SEAL 3 level is on the slide. However, what does it mean? It's also really simple things. SEAL 3 level means that the system cannot proceed 1 per 10,000 requests. It's a really good parameter. For the system, it means that system should include just reliable components, and the system shall have the self-diagnostic coverage better than 99.8%. Such type of system will allow you to detect all possible faults. And in case when the critical fault has occurred, it happens sometimes, the system will go to the safe state and no damages will be around. Let's consider some example from real life. What is reliability? It's a 30-year marriage. What is safe state? Safe state, for example, the kettle. No water, the kettle is switched off. When we talk about the self-diagnostic, let's consider the situation with the car. All of you are driver or passengers in the car. And many cars have such type of a sensor named tire pressure monitoring system. Of course, car will work without it, and it will be a really good car. However, what do you prefer? To see such type of difference and find the nearest pit stop at the start of your trip, or stop the car in the middle of highway because of flat tire? So we discussed safety and self-diagnostic, but safety, self-diagnostic, and maintenance are also connected together. When we talk about INC, INC includes cabinets. Cabinets include programmable logical controller or chassis. PLC includes different type of modules which receive, process, and send the information to the other system, or control different type of process at nuclear power plant. When we talk about our INC system, it's based on the Radics platform. Radics platform has such type of safety level like SIL 3-in-1 channel. It is FPGA-based platform, and it is a platform which has the exception of US NRC to use in the safety INC system and nuclear market in US. This platform has the self-diagnostic at different level. First level is a system level. Second one is a cabinet level. And the third, each particular module. I would like to show you some practical cases related with it. This is our baby. This is our platform. So the first case, let's imagine that one of the sensors in the reactor is out of range. It means that our system shall react for it. It will be such reaction in the system level. You can see it on the screen and on this screen too. Also, we can see it on the module level. Give me a second, please. Okay. Alexander, where are you? Please help me. Where is the mouse? I forgot it. Что тут с мышкой? Okay, let's consider on the system level. We will show you a little bit later. And of course, when we open the module, we can see it an even module level. What exactly? Вверх. Давай, все. Okay. So everything is okay. It was not the safety system. It was just a mouse for computer. So we can see such type of picture. When we open, for example, analog input module, we could see what exactly goes wrong, that such type of signal was out of range. So let's return it back to the normal parameter. And everything is okay. The second case, for example, is when the loss of communication. If we lose one of the optical connection, we can see the alert on the logic module. It is not critical fault, it is because we can see just an alert, not a fault. And when we open the logic module, we can also see what exactly goes wrong. Let's return it back. And the system goes to the normal operation. And the last case, Let's imagine that one of the modules was damaged. What we will see, the system also should detect it. We can see that logic module is red, analog input module which was damaged is also red, and this is critical fault, and it means that the system shall go to the safe state. When we open the analog input module, we can see that everything is red, it is broken. And when we open one of the output module, we can see what happened exactly. So we discussed maintenance, safety, and self-diagnostic. But where is investment in this chain? You know that all equipment at nuclear NPP shall be tested regularly. The type of tests, the quantity of such type of tests depends on the type of reactor, depends on the equipment, depends on the regulatory policy in this particular country, depends from the work instruction and this NPP, etc., etc., etc. However, there are some common type of testing which will be used in each NPP. The first one is daily check. Let's consider the situation that we have, the analog safety INC system, for example, reactor trip system. It means that for such type of system, we shall perform every day the testing, daily check, during 2-3 hours. We need for this testing 1-2 staff, and we shall perform this test for each of the channel in nuclear power plant, and quantity of channel depends on the system architecture. And it means that these 2 people every 365 days should fill out a lot of paper, not just perform the work, they also should prepare many papers. Another most common type of testing for all nuclear power plant is quarterly testing. This type of testing takes average from 8 to 10 hours. It takes 3-5 staff to perform such a type of a test for all channels. And the quantity of such type of functional tests is from 15 to 35 tests. And of course, these people should fill out a lot of paper. Let's consider how we can translate it into hours and money. For daily check, it will be 2 hours, 2 people, 4 channels, 365 days, and it will be almost 6,000 hours. For quarterly check, it will be more than 10,000 hours. Let's consider $100 as a payment cost for now for the 1 hour. It will be $1,600,000 per year. But if you use the safety INC system more than 15 years, it will be more than $24 million. You can tell me that it's not so big money for safety. However, what if you have the system with comprehensive self-diagnostic? The daily check could be reduced to half an hour. The quarterly check could be reduced for 2-3 hours, and you need just 2 people to perform such type of testing. And of course, these people should work just the diagnostic computer, and all results of the tests will be saved automatically. Let's translate it into the hours and money. It will be 1,400 hours for daily check, For quarterly check, it will be just a little bit more than 1,000 hours. When we translate it to money, we can see that it will cost just $274,000. For 15 years, it will be something like $4 million. The difference is amazing. You can see that time will be reduced in 5 times. And in money, the difference will be more than $22 million for 15 years. I understand that $20 million for 15 years for nuclear, it's not so big money. However, if you have 20 million, better give it to me. I know how to spend it. So the solution is obvious. Radics platform for UNC modernization is a good solution. Radics can bring you money. Just check it. Thank you. Thank you, guys.